Example 10 of force and motion under the frictional force. A woman pulls a mass M equal to 75, mass M equal to 75 kilogram along horizontal. So this is supposed to be horizontal. You might want to change this to or add HO here. Along a horizontal surface at constant velocity, the coefficient of, there's going to be coefficient of, there should be of here. So the coefficient of kinetic, this is supposed to be K, isn't it? Coefficient of kinetic friction mu K between the runners and the horizontal surface is 0.1, and the angle is 42 degrees. So the question A part says, what is T? Okay, what is T? T should represent tension. So what is going to be T? The first step in going ahead to solve this problem would be to draw our XY plane and see what this looks like on the horizontal, our coordinate axis. To do that, you probably want to check this out. All right. So we're told that a woman was pulling. Okay. So to pull something, it simply means that you're going to attach a string to it, isn't it? A string or a rope or a cord. You're going to attach a cord to it before you can pull it. So the woman is pulling a mass. This is the mass here at the middle here. We have the mass represented at the middle here, and then we have the woman pulling it this way. So if you are pulling, there is going to be a cord here. So this is the cord that is being used to pull. That is where the tension is going to be. So once there is a cord, then we can easily say, okay, there is going to be tension in that cord, and that is the T that we are looking for. So a woman pulls a mass M equal to 75 kilogram along a horizontal surface at a constant velocity. Okay, so if they are pulling at a constant velocity in this direction, of course, it simply means that there is going to be a force acting downward. That force is going to be the weight of that particular mass. There's going to be another force acting upward. That force is going to be N, right? So that force acting upward is going to be N, which is the normal force acting on the body. And then there is going to be Fk. What is Fk? So the angle the body makes with the pull is 42 degrees as given here in the question. Okay, so that represents this particular phi. Once you can draw this diagram, every other thing becomes very easy for you to deal with when you try to solve problems. So let's take it a step further. Once you have this, the next thing you want to do is try to create your equations. Let us look for the solution of all the horizontal forces. The horizontal force, we are going to convert this T to horizontal component. This T is at an angle, so we want to convert it to horizontal component. We already have our Fk. Fk is in the negative direction here. Can you see that? Fk is in the negative x-axis, so it's going to be minus Fk. So you can see we have minus Fk here because it is in the negative x direction. You can see T, if you convert it to horizontal, is going to be in the positive direction. Okay, so you have summation f of x equals to, if you convert this T to horizontal component, it becomes T cos phi. Phi is the angle between the tension, the cord, and then the horizontal axis. You have T cos phi minus Fk equal to 0. All right. Why is it equal to 0? Normally, summation of f of x should be mass times acceleration in the horizontal axis. But then we were told that it is being pulled at a constant velocity. If it's constant, that means acceleration is going to be equal to 0, isn't it? So if ax is equal to 0, that means the entire max here will be equal to 0. So you have T cos phi minus Fk equal to 0. All right. This will be the horizontal expression that we have. You can label that as equation 1. Then you can go ahead and say, okay, what about the vertical? Summation f of y. For summation f of y, what you would have is, how many vertical forces do we have here? We have N, we have W. We can also convert this T to its vertical component, just as we can convert it to the horizontal component. N is positive, so you can see we have plus N here. It's positive because in positive y-axis. Weight is negative, right? You can see weight is negative y-axis, and the weight normally should be equal to mg, the mass times acceleration due to gravity. So weight is in the negative x-axis, so this is the minus mg. You can see we have minus mg here. Okay, this T to its vertical component, this T becomes T sine of this particular angle. Can you see that? It becomes T sine of this particular angle. So that's why we have T sine phi plus N minus Ng. All right. ay would also be equal to 0, so may would be 0. So you can say that t sine phi plus n minus mg equal to 0. So you can label this as equation 2. So we have two equations we can play with right now. All right. We also know that our Fk from our initial, discussion, our Fk, which is the kinetic friction at first, is equal to mu k multiplied by n. So this can be your equation 3. All right. Let's take it a step further. From what we have here, if Fk equal to mu k multiplied by n, what you will find here from this particular expression, we already know that our t cos phi minus Fk is equal to 0. From equation 1, t cos phi is equal to Fk, which is what we have here, and we already know that our Fk will be mu k n, so you can just say t cos phi is equal to mu k n. You will find out that we can go ahead and just easily say that our n, if you rearrange it, is equal to t cos phi divided by mu k. What else again can we do? From equation 2, we said that our t sine phi, plus n minus mg would be equal to 0. That is what we said from equation 2, isn't it? So t sine phi plus n minus mg would be equal to 0. So if you have that, what you can do is say t sine phi plus n. Now we have our n to be equal to t cos phi over mu k. You can put that here, t cos phi over mu k minus mg. It's like we're trying to solve a simultaneous equation right now. Okay, so I shouldn't be teaching you how to do that, but let's just go through this together, because I feel you guys can solve simultaneous equations yourself, and you can use any method to do that, and that's what we're trying to do here. So t sine phi into equation 2, t sine phi plus n, which is t cos phi over mu k minus our mg, will then be equal to 0. All right, if you have that, you can then go ahead and say that if you cross multiply, all right, if you convert this to a linear equation, this is a fraction here. So if you make this a linear equation, you have t multiplied by mu k sine phi plus t cos phi equal to mg mu k. Now you guys can solve this particular three simultaneous equations using any method you like. I'm just showing you the method I use, so you can see how I substituted words into words. All right. So, but you guys, when you're solving your problems, you can use any method you want. You can apply the values of the variables we have at any point in time and the constants that we have at any point in time. Okay. So let's follow closely. So if we have that, it simply means that you can now begin to find a way to substitute. Since our t from this equation, I can make t the subject. For example, I can bring t out. All right. Probably before I do this, I can show you something very important here. What you will find out here is that you can have t here. You can write t and then open a bracket. And what you have here is going to be mu k, right? Mu k sine theta plus cos theta. Or probably it's cos phi we are using, so it's sine phi cos phi. You can have that equals to mg dot mu k. So if you want to find your t therefore will then be equal to this divided by, you just bring this here as the denominator. All right, and that is exactly what we did. That is exactly what we did to obtain the next item that I'm going to show you, or the next equation I'm going to show you right now. So you can see now that we have t equal to mu k multiplied by mg divided by mu k sine theta plus cos sine phi plus cos phi. All right, so that is exactly what you have here. We know from the question given to us that mu k is, what is our mu k from the question? Is 0.1. Mu k is 0.1. As you can see, we have our mass m from the question as 75. So we have m 75. We put that here. Our g is 9.8 meters per second squared. You could use 10 if you want to make the calculations easier. Divided by mu k sine phi. We already know another mu k is there, 0.1, and then we have sine phi will be equal to sine 42 plus cos 42. If you find out what is going on here and you carry out your arithmetic, addition, subtraction, division effectively, you will find out that your t will be equal to 91 newtons. How to convert forces, how to convert to horizontal and convert to vertical. If you draw a stick here like this, this line here, this becomes a right angle triangle, right? So if this is a right angle triangle, this is going to be, and you're considering this angle, this is going to be your opposites, isn't it? This is going to be your adjacent, and then this is going to be your hypotenuse. What is sine theta going to give you here? Sin theta is usually opposite over hypotenuse. So your sin theta would be equal to your opposite, which is here. All right. This is going to be this. What is here is your vertical, right? This is your vertical component. This is going to be the vertical component. So it's going to be opposite all divided by the hypotenuse, which is h. If you are looking for the vertical component, this opposite is going to be your ty, the vertical component. Your ty, the vertical component, will be equal to h sin theta. Okay, so you can just put your your t here. For vertical component for t of t, it should just be equal to t sin theta, and that is why we use for vertical we use t sin here. The same thing would be for the horizontal component. If you want to do horizontal, you use cos. Do you understand that now? There is a B part of the question. There is the B part of the question which says, what is the normal force with which the snow pushes vertically upward on the sledge? On this place, you can change this place to snow. This is supposed to be snow, by the way. So we are pulling the sledge on the snow. The horizontal surface is the snow. Okay. So what is the normal force with which the snow pushes vertically upward on the sledge? All right. To do that, the normal force N is what we are looking for, and we already have an equation and expression for the normal force. All right. So to find the normal force, it's just going to be T cos squared all divided by mu k. So if you do that, this is what you obtain. T cos squared by mu k. We know our T. We calculated it to be 91 newtons. We have cos 42 as our file is 42, so we have cos 42 divided by 0.1. So your N is going to be 676 at the end of the day. If you want to ask me any questions now, is a good time to ask me. If you're not asking me now, probably you can ask me in the comment section.